Hi everyone. So today we are going to talk about random forests, which is an extension of our previous topic, decision trees. So in decision trees, we talked about how we can categorize something using a decision tree. So we'll have some decision nodes, and then we'll also have some leaf nodes. So let's call this leaf node. So when we are given a data point, we can go here and check what the decision is, and depending on that we can either choose to go this way or this way. And likewise, when we go through the entire decision tree, we will be able to decide how to categorize or how to take a decision regarding that particular data point. So how do we go from decision trees to random forests? Right. So generally, what is a forest? So a forest is, like we tend to say in real life, it's a collection of trees. So there itself you have a hint on what a random forest is. So let's see, why do we need to have random forests, right? Why random forests? So this should be in order to prevent some disadvantage of our decision trees. So what we saw earlier was that decision trees are I'll say decision trees, they are very sensitive to training data. So you may slightly change a data point, and you can see that so I'll just mention it here, change a data point slightly. Let's add slightly because this is important. If we slightly change the data point, we'll have a completely different tree. So what happens is, as a result of this sensitivity, decision trees may fail to generalize, because we want to find out a generalized representation of our data set, right? So this may fail to generalize, so this means this has sensitivity issues regarding our training data. So let's see how we try to prevent this, right? So, or how we are trying to prevent this, or in other words, how to build a random forest. Call this RF from now on, right? Let's see how we are going to go about doing this. So let's come up with a sample data set. Let's say we have several data rows, A, B, C, D, E, F, right? So, and we have different features, x0, x1, x2, x3, x4, and then we have our target variable, right? So let's say this is a binary classification, so we may have something like, okay, let's say we have two categories, right? 1, 2, 1, 1, 2, 2. So given a data point, we want to find out whether this falls under category 1 or 2. So we can make a decision tree for this, but that would be quite sensitive. Like, for example, let's say we make a decision tree, something like this. Then we go ahead and change the x3 variable of C. Let's say, for an example, we change it. I'll put a delta there. So this would result in maybe a whole node shifting or something like that. So this could result in our decision tree changing. So this is why we are trying to come up with random forest. So let's see how we are going to build a random forest. first step 1 of a random forest is, let me bring my data set over to the other side. Okay, we are going to create a new data set by randomly sampling. So create new data set by randomly sampling from original dataset. So this is sampling with replacement. So let's say we have 1 2 3 4 5 6 data points here. So let's create a new dataset. So we'll randomly select 6 data points from our original dataset. So okay, let's say the first random one is C. Then we get E, A, C, B, A. So this is our new randomly selected dataset, right? Because we are randomly selecting with replacement, we get like repetitions of certain data points like seen here. But that is all right, because we are going to create multiple trees similar to this one. So I'll just so now we have selected a random set of data points, and now we are not going to stop at that. See how we have 5 features here. We are going to randomly select, let's say 2 or 3 features from here. So let's say for this one we are coming up with for this one we are coming up with x1, x3 and x4, right? So the rest are going to be discarded. And now we have a dataset which has the properties of our original dataset but is a randomization of it, right? So now what we are going to do is so we created a new dataset, and we selected some random features. So this step can be called the bootstrapping. This is the bootstrapping step. Actually, like, this is step 1, and selecting the features, this is step 2, right? And step 3 is creating multiple decision trees using the above process. So now we have created several datasets like this, and we are creating multiple decision trees for those datasets. So we may have one decision tree like this, and another decision tree which is very bad, then another random one. If there's like, if everything in a certain dataset is of the same type, then we'll just have this. So as you can see, we have like a range of decision trees, and they are representing various features. So these represent various features, and so some of these are sensitive to some features while others are not sensitive at all, and we have different data sets as well. So this is a more generalized representation. This is the random forest, which is a more generalized representation. And now when we have a data point coming in, a new data point, we will send this. So let's say we have a new data point, we'll send this through this tree number 1, and we'll get, let's say, 1. Send it to third one, it will get 2. Send it to the second one, gets 2. send it through the third tree, this will again return 1. Send it through the last one, and let's say it also returns 1. So now what we can say is it's more probable that this new data point, this is our new data point, it's more probable that this new data point belongs to the category 1. So we take a vote amongst the decision trees in the random forest and take our decision. This is called the aggregation step. So yeah, so that is what a decision tree is. So when we consider these two or 3 steps, we have a bootstrapping step and an aggregation step. Altogether, this is called what you call bagging. In machine learning, if you hear bagging, so this is what's happening. So let's see, what does bootstrapping give us? It provides us with the advantage that our trees are less sensitive to training data. And with the aggregation, what happens is there's a low correlation because we have different features represented by each tree, and we say that the ideal number of features to be selected is around if the number of total features is n. For aggregation, we should take the root of that number. So number of features for random forest would be the square root of the number of features in the dataset. So I think that covers our lesson on random forests. So thank you very much for joining, and next week we can move on to a completely different topic in unsupervised learning. All right, thank you very much.